Greetings, students and families. Welcome back to this edition of Mr. Wong's Distant Learning. Today's lessons for April 2nd and 3rd, 2020, and for both the standard and advanced classes. We will be discussing mean absolute deviation. This relates really closely to mean, where you add up the total values of all the numbers in a data set and divide to find an average. The homework for standard would be page 460, questions 4 through 8 in the math workbook. And for the advanced class, homework is 9.5 in eCampus. Let's continue by reviewing how to find mean and median. The biggest concept to take away from the lesson is which of the two, mean or median, would you use to describe the data the bestest way possible. In this example in the reflection question in the workbook on page 452, the scenario reads, Luca's final exam scores for this semester are 70, 72, 99, 72, and 69. Find the mean and median. Which is a better description of Luca's typical exam score, and explain your thinking. Let's follow the on-screen steps to find the mean. Step 1. Add all the numbers together. Step 2. Count how many numbers there are. And step 3. Divide the total by how many there are. Let's have a look. If we add all the values in the data set, we will receive a total sum of 382. Divided by 5 for the 5 values in the data set, we have a mean of 76.4. Let's also now find the median. Let's look at the steps. Step 1. Order the numbers from least to greatest. And step 2, find the exact middle number. And if there are two middle numbers, add them together and divide by 2. One of the common mistakes that I've seen for all the homework submissions is that many students just find the middle number and assume that is the median. In this case, 99 is the absolute number in the middle of this list, with 2 numbers to the left and 2 numbers to the right. Does that mean 99 is the correct median? Certainly not. We must follow the first step and order the numbers from least to greatest. In this case, 69, 70, 72, 72, and 99. The median is the absolute middle. If we draw rainbows from each number, we find that 72 is by itself, and the correct median is 72. Which of these is better? Median is better because 76 for the mean is a lot bigger than most of the numbers here in the data set, while 72 looks like a better average since it's in the middle. Remember, it's important to follow the steps to accurately calculate the mean and median. As suggested previously, do go ahead and use a calculator for your calculations. The work required to be shown to receive full credit for homework is just shown just like this. Write out the mathematical expression to show the sum and the total, and write the expression of the division problem, and also give me the resulting quotient. This is sufficient work, and using the calculator will help us ensure that our answers are accurate and precise. Let's take some time now and make sure you have a notebook, and for the standard kids, their workbook and also writing instrument. Let's take a look at the following steps again for mean and median, and do document this into your notes. Reviewing to how to find mean. Step 1. Add all the numbers together. Step 2. Count how many numbers there are. And step 3. Divide the total by how many there are. That's how you find mean. To find the median, follow these current steps as well. Number 1. Order the numbers from least to greatest. Number 2. Find the exact middle number. And part A, if there are two middle numbers, for example, if the number set has an even amount, add them together and divide by 2. The trick or rule is that if a data set has an odd amount of values, there will always be an exact middle number to be the median. If the data set contains an even amount of values, you'll have to find the two ones in the middle and add them together to divide by 2. Pause now to take these notes, and then resume once you've completed. Hi folks, welcome back. Let's proceed to the next slide. Students in the standard class, go ahead and follow along in your books on page 455. Advanced class students, go ahead and take some notes as appropriate. This section is calling Understanding Mean Absolute Deviation. A measure of variability is a single number used to describe the spread of a data set. It can also be called a measure of spread. One measure of variability is the mean absolute deviation, MAD, which is the mean of the distances between the data values and the mean of the data set. Before we continue reading the steps at the bottom of the slide, let's take a look and put it into perspective. Imagine you're staying after school, maybe for a club meeting, and your mom says she'll pick you up at 4:30. Sometimes she arrives on time, sometimes she arrives a little bit before or a little bit after 4:30. On average though, how far apart is she off from picking you up? Maybe she's about 5 minutes early, maybe 5 minutes late. That number, 5 minutes, is the average difference of the times that vary from the average. That's what mean absolute deviation is. Another scenario would be if your grade in the class is a 92%. Does that mean that every assignment you completed and submitted was 92%? Or maybe the grades averaged out, some highs and lows, maybe a couple of 88s. And the question we have to answer is, how far apart are your real grades from that average of 92? Again, this is what the mean absolute deviation is. Let's describe it in another way. The mean absolute deviation is an average of how much data values differ from the mean. Go ahead and copy these into your notes. The key ideas are to find the mean absolute deviation. Step 1, find the mean of the data. That means adding up all the data values in the set and dividing. Step 2, find the distance between each value and the mean. You do this by subtracting the mean and the numbers in the data set. Step 3, find the sum of all those distances in step 2. And finally, step 4, divide the sum in step 3 by the total number of data values. You're almost like you're finding the mean twice for each problem. Pause the video now and take some time to take these notes before proceeding to the examples. Let's look at some examples now. At this point, I would suggest maybe you have yourself a calculator so you can follow along. The examples shown here are step by step, and what you may see in the booklet is very different from what you see on screen because I will work these out step by step. In this scenario, the data represents the height in feet of various buildings. It's asking you to find the mean absolute deviation for each set. On the right is the steps to how to find mean absolute deviation as a shortcut we can refer back to at any time. Step 1 is to find the mean of the data. Round to the nearest whole number. In fact, with our calculators, we can get the exact mean, but let's follow along. If we were to add 60, 58, 54, 56, 63, 65, 62, 59, 56, and 58 together, we get a mean score of 59. Now why did we divide by 10? That's right, because there are 10 numbers in this data list. From here, we have to figure out how far apart this mean is from the original values here in this list. At this moment, how far apart is 59 from 60, as well as the other numbers? Go ahead and find the differences now of each of these by writing the correct amount inside these boxes. I'll wait a moment while you continue. Please pause the video now to complete this activity and then proceed to check your answers. The differences you should have received between 59 and the rest of the numbers in the data set are 1, 1, 5, 3, 4, 6, 3, 0, 3, and 1. I do notice that some of the numbers are bigger than 59, while some of the other numbers are less. But because we're finding the absolute deviation, we're just trying to find the distance from one number to the next. There are no negatives here. At this time, now that you have all the distances from the mean, our next step is to find the mean of these new numbers by adding for a sum and then dividing by, again, 10 different values. Once we've added and divided by 10, we will see that we will get the answer of 3. Remember, we are adding the differences up and still dividing by 10 because there are 10 values. The final result would be a mean absolute deviation of 3. What this means when you interpret it is that although the mean is 59, as related to the data set, the average distance or difference between the mean and the real feet of the buildings is about 3 feet. That would be like saying your mom arrives again at 4:30, but is about 3 minutes early or 3 minutes late. That's what this average difference means. Let's move on to part B. At this time, I want you to find the mean absolute deviation using the steps here in the right red box. You'll have to find the mean and then find the differences from that mean with all the values in the data set before finding the mean of that. At this time, try your best to try and find the mean, the differences from the mean, and then the mean of those differences. Pause the video now and resume to check your answers to see how we did. Remember to round your answers to the nearest whole number so we have whole numbers to work with. Try your best. Welcome back, folks. When we get the sum total of all 9 values, we must divide by 9 because there are only 9 numbers in this data set. The resulting mean would be 50 once rounded. Do you guys remember what to do from here? That's right. We must compare the 50 and find the differences between all the rest of the numbers. Now, you don't have a chart made out for you in the book, but I myself made a chart just to keep track of the numbers. This continues on page 456. How far apart is the 50 from 46? How far is it from the 47? And so on and so forth with the other numbers. We should have been able to calculate that the differences would be 4, 3, 6, 2, 4, 2, 7, 2, and 5. From here, we must find the mean of those differences. We should have added all those up and then proceed to divide by 9. In this case, our total mean absolute deviation after rounding would be approximately 4. You've just figured out how to find mean absolute deviation. Remember, mean absolute deviation is just the average difference for which the mean differs from the rest of the values. Let's continue with the reflection question on page 456. Analyzing relationships, comparing the mean absolute deviations. How do the mean absolute deviations describe the distribution of the heights in each group? In this case, part A had a mean absolute deviation of 3, and part B has a mean absolute deviation of 4. Let's think about this in another context. Let's say that your mom was supposed to pick you up after school and says she will arrive in 30 minutes. In several cases, she did arrive in exactly 30 minutes, while other cases she arrived at 29 minutes, 25 minutes, and in one instance she arrived at 33 minutes, and another 37 minutes. Those numbers are pretty close to the 30 minutes which she stated. However, we have to find out how much off she usually is. Again, this is the mean absolute deviation. What's the average difference that she's usually off by? What if there are 2 separate parents that also pick up their child and arrange that they'd pick up their kid in 30 minutes? What if one parent was off by 3 minutes than normal and another parent was off by 15 minutes than normal? It could be 15 minutes earlier or 15 minutes later. What does a larger mean absolute deviation mean when compared to a mean absolute deviation that is smaller? What if one parent was never off and always picked the child up in 30 minutes? What do you think that mean absolute deviation would be? That's right. The larger the mean absolute deviation, a larger number, it means that the average is actually a lot different than the real numbers in the set. Relating back to the question, the mean absolute deviation in part B is greater. The heights in part B are more spread out than the mean of the heights of part A. These are called measures of variance. A measure of center is a number that indicates where the middle or center of the data is, while a measure of variability is a number that indicates how much the data are spread out from the center of the data. Let's continue. On page 457 of the Go Math Workbook is the Your Turn section, starting with number 2. All students in Standard and Advanced, please attempt these math problems. The scenario reads that 2 waiters at a cafe each serve 10 large fruit smoothies. The amount in each large smoothie is shown below. Which waiter's smoothies showed less variability? So our goal here is to find the mean absolute deviation. Do you remember the steps? Remember to consult your notes on the steps to find the mean absolute deviation. Do remember that we're using calculators to help us with our calculations. Do, however, still round to the nearest whole number to help us aid in finding these mean absolute deviations. Don't forget to show work. Pause the video now to try and finish this task and resume once completed. I'll talk to you soon. Welcome back, folks. Let's take a look at waiter A's mean and then mean absolute deviation. Our first step is to add up the sum of these 10 values. Once completed, when we add it together, we should receive a value of 199.9. Rounded out, it would be 200 divided by 10, which gives us a mean of 20. Now let's find out how far this is from the numbers in the list. We do this by finding the difference subtracting. By comparing these, we figure out that 20 and 19.1 are only 0.9 away. We do the same fashion for each of the 10 numbers in this entire set. Remember, the next step is to add up these differences, and together we get a whole value of 5. Once more, we divide this by the number of values we added together. So we divide by 10 and receive a mean absolute deviation of 0.5. The mean absolute deviation of waiter A is 0.5. Let's perform the same method and tasks and procedures for waitress B. Again, we must find the mean first. Let's add all these values together and see what we come up with. When we add up all the values together, we will receive a total sum of 200.1. We divide this by 10 because there are 10 numbers. Rounding the total to 200 divided by 10 gives us the same mean as waiter A. Let's find out how far this number is from the numbers in the list. We'll subtract again. Comparing the mean of 20 to the numbers in this list, we find out differences by subtracting. Here are all the differences that the values in the original list are from the mean of 20. Our next step to calculating the mean absolute deviation is to add up all these values and divide by 10. When we do this, we have 2.0 as the total, and then divide by 10 since there are 10 numbers. We get the answer of 2 divided by 10 and get 0.2. The mean absolute deviation for waiter B is 0.2. Just like in the guided example, let's compare these two mean absolute deviations. We have 0.5 compared to 0.2. Answering the question, which waiter's smoothies showed less variability or are not as different from the mean? You guessed correctly, waiter B. Remember, the smaller the mean absolute deviation, it means the closer the numbers in the list are to the mean that we've calculated. All these numbers in the waiter B's list are actually very close to 20. While in waiter A, they're a little bit farther than 20, but just really close. The difference is quite similar. What if there's a mean absolute deviation of 0? What would that mean? If the mean absolute deviation is 0, it would mean that all the numbers inside the data list are exactly the same as the mean. For example, let's say you get 100% on every assignment in a class. What do you think your average in the class would be? You've guessed it, you'd have a 100%. Now how does your average of 100% compare to the grades you have in the class and the assignments? Exactly 0. They're 0 off because 100% is the same score as the scores on your assignments. There is no deviation. Let's review the steps to calculating and finding mean absolute deviation. Do you remember without looking at your notes? Let's find out. Step 1 is to find the mean of the data set. We do this by adding up all the numbers together, dividing by the total of how many numbers are on the list, and that's your mean. Step 2 is to take that mean from step 1 and find the distance by subtracting each of the values in the data list. This will give you another list of numbers. And then step 3. Add up all these differences together and then divide by how many values there are. In most cases, you'll be divided by the same number you did in step 1. This is your mean absolute deviation. Now on page 459 is guided practice. Take everything you learned throughout this video, rewind it any time you need to, and do consult your notes and use your calculator to help you calculate this. Guided practice questions are a good way to help us practice, and after we resume the video, to check your answers before the homework. I'll read the context clues and question for number 1. A bus route takes 45 minutes. The company's goal is to have a mean absolute deviation of less than 0.5 minutes, or half a minute, 30 seconds. One driver's time for the 9 runs of the route are shown. Did the bus driver meet the goal? Again, the goal is to have the bus driver be off by half a minute on his bus route. The times to complete the bus route are 44 minutes, 0.2, 44.9 minutes, 46.1, 45.8, 44.7, 45.2, 45.1, 45.3, and 44.6. You'll see that it actually separates the steps so that you'll calculate the mean first in part A before you calculate the mean absolute deviation in part B. Then it answers the question. Did the bus driver or did not the bus driver meet the company's goal? Pause the video now to work this problem out before checking your answers when you resume. In this case, do not round your answers off because we are actually comparing to a decimal value. At this time, pause now. Welcome back. Did you receive the same mean and mean absolute deviation that will appear on screen? Check your work now and let's see. If we add up the total of these values and again divide by 9, we get a mean of 45.1. Then when we calculate the mean absolute deviation, we take the 45.1 mean and find the difference of each of these values to the mean by subtraction. We then take the new list of numbers, the differences from the mean, and add those together and once again divide by 9 to get a MAD of 0.4. Remember, the company's goal wanted to have a mean absolute deviation of less than 0.5. Is 0.4 less than 0.5? Did the bus driver meet his goal or not? In this case, the bus driver did. Please take some time to review some of the notes and some of the examples in the previous slides by rewinding as needed. So, what does the mean absolute deviation tell us about the data sets? What if the mean absolute deviation was small? What if the mean absolute deviation was large? What if the mean absolute deviation was 0? So what does the mean absolute deviation tell you about a data set? That's right. It is the mean of the distances between the data values and the mean of the data set. It can tell you how spread out the mean of the data values are. If it's a smaller mean absolute deviation, that means all the values are really close to the mean. If they're farther away, it means that the numbers in the data list are very different from the mean. Now it's time to check your understanding with the homework assignment. For our standard group of students, your homework's on page 460, questions 4 through 8. Remember to use a calculator to help you with those calculations and speed things up. Make sure to show that you're adding all the numbers up in a string similar in the example we've shown before. Students in the advanced class will be doing 9.5 homework that is available on eCampus. Homework submissions will be due on the assigned Friday at the end of the week, before midnight. Glad to see you guys signing in and submitting homework, and I'll see you next time. Stay safe.